the easiest thing for this lesson will be simply just to look at the kinds of problems that we're going to do. Because what you're going to be doing is you're going to be solving triangles. And what that means when you solve a triangle is that you have to find any missing pieces that you might have. And these triangles are all going to be right triangles. The angles are going to be labeled as uppercase letters. C will usually be the right angle, and you'll notice on page 123 in your book they've given you a drawing like that. The sides across from each angle will be labeled as a lowercase of the angle. So the lowercase letters represent the sides, the uppercase letters represent the angles. Remember that when you add two angles together and they add up to 90 degrees, that's complementary. So since in a triangle, the triangle has 180 degrees total, that means that A, B, and C add up to 180 degrees. Now, since it's a right triangle and C is 90, it means that A and B add up to 90. So if you know one of these angles, for instance, if A is 30, that would make B 60 because they both have to add up to 90 degrees. So that's one of the things that's going to happen in all of these. So let's just jump right in. Let's look at page 123, and let's just go ahead and look at number 10. I'm going to draw a triangle, and I'm going to label it. And I'm going to label the things that they give me. They tell me that A is 18.4 degrees. So I'm going to put 18.4 in there. And they tell me that little c is 0.0897. And it wants us to round off the results. So let's just take a look at it and let's see what we've got. So B, C. If little c is 0.0897, that means it's the one across from the big C. So that's what we've got labeled. That means that in order to finish this problem, we need uppercase B, lowercase b, and lowercase a. So we're going to use our trig functions. We're going to use the main three, sine, cosine, and tangent. And remember that sine is side opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So we're going to use those things to find these missing sides. One thing that I can do here, if I start with the angle, is that since I know one of the angles and I know those two have to add up to 90, I can say 90 minus 18.4, and that will give me that missing angle. So a missing angle is 71.6 degrees. So that means that angle B is equal to 71.6 degrees. So that's one of the things that's missing. I also have side A. So let's see, let's work on side A for a minute. Let's erase some of this work down here so that I have some space to write in. And if I'm looking for side A, and I have angle A, little a is opposite from that, and I have the hypotenuse. So I can use one of the trig functions involving hypotenuse. I just need to know which one. I'm looking for A, and it's opposite of angle A, so opposite of A would be sine. So I can use sine of 18.4, and I can set that up as little a over 0.0897. Now, once you do this, it's just basic algebra. You're going to take your calculator and punch in the sine of 18.9, and that comes out, if I round it, I'm going to round it to 4 decimal places because that's usually what we do traditionally. If you get something a little different than the back of the book, you've just probably rounded differently than they have. Now, if I put a 1 under this, I can cross multiply like a proportion, and I can say that a times 1 is a, and I would get A equal to 0.3239 times 0.0897, and I would get that A is equal to 0.0, let's round to the hundreds on that, 0.03. My calculator actually says 0.0290538, and I'm going to round to the hundredths, and I would get that A is 0.03. So now I'm simply missing the small b side. So let's find that one. So little b is here. We had found big B, and big B was 71.6. We already had the hypotenuse, which was 0.0897. So I could use sine again if I wanted to, because little b is across from b, so that's side opposite. I could also, if I wanted to, I could use this angle that's down here, which is A, and it's 18.4. And I could use cosine because B is beside that one. So I can use any one of these that I want to, as long as I have enough pieces to do an algebraic equation. So I'm going to do sine of 71.6 is equal to little b over 0.0897. You'll just need to be really good at your basic algebra. So sine of 71.6, and like I said, traditionally we round the trig functions to 4 decimal places. So 0.9489. That's what shows up on my screen. If you're not getting this on your calculator screen, make sure that your calculator is in degrees, like we talked about in another video. I can turn this into a proportion, and I can get that B is equal to 0.9489 times 0.0897. And I end up with B equals 0.09. So I found all the missing pieces of that triangle. And that's what you're trying to do with these, is find your missing pieces. We probably want to do one that has some missing angles on it though. So let's do one that's like that. Let's look at, let's see, in your book, if we look at number 12. Number 12 gives me little a is 932, so that's the one across from big A. And it tells me that little c is 1240. So I'm looking for, and let's make that look like a real 4 instead of a 9. But I've got to find A and B, and I've got to find little b. So those are the things that are missing in my triangle here. Let's make that a 4, make it look like something you can actually see. Okay. So let's see what would be the easiest thing to do first. Let's look at the pieces that we have. If I need to try to find the A, I have an opposite and I have the hypotenuse. So I could use sine of A equals opposite over hypotenuse. Now, in some of the problems that we did, we actually found angles on our calculator, and there is a button on your calculator that looks like this. I'm going to pull up the calculator so you can see it. Let's just pull this calculator up. Anytime you're trying to find a missing angle and you're not given another angle, you need to use that button on your calculator. So let's clear out what we've got. And I had 932 over 1240 as my ratio. So if I hit second sine and I put 932 over 1240 and I hit enter, it is going to give me the angle that it came from, and it just depends on what the problem tells you to do with rounding. This one is very general, and it just says round off the results. So we're going to round off this one, we're going to round it off to 49 degrees. So let's go back to my problem, and I'm going to say that A is 49 degrees. Now, if A is 49 degrees, and I'm missing b, all I have to do to find b is do 90 minus 49, and I get 41 degrees. So b is 41 degrees. So now I have a is 49 degrees, b is 41 degrees, and the only thing that I'm missing right now is the lowercase b. So if I know now that b is 41, just pop that up there. It's getting a little messy. Little b is side opposite, and I have hypotenuse, so I could do sine of 41 is equal to little b over 1240. And I can take my calculator and do sine of 41. Let's pull up the calculator. Sine of 41 is equal to 0.6561. And I can do a proportion. And I can multiply 0.6561 times 1240, and I get roughly 814 if I round. So little b is roughly 814. So I found all my missing pieces of that triangle. So just keep in mind that if you're trying to find the angles, if you're given one angle, you can subtract it from 90. If you're given no angles, you're going to need to use the inverse key on your calculator. And if you're given some of the angles and you need to find sides, you just need to use your trig function.